Hello, this is Tom from Hazmat Strategies. We are a training company that specializes in teaching hazardous waste operations and emergency response with a specialty in how this applies to people who typically work in household hazardous waste collections. In our classroom, we spend a fair amount of time teaching our students the 9 Department of Transportation hazard classes and helping them understand the potential hazards, what they can do to your body, how they can harm you, how to identify these chemicals if they come in as an unknown chemical, and how to protect themselves from harm in handling these chemicals. We also like to get outside the classroom and do some outdoor chemistry demonstrations. The purpose of the demonstrations are to help drive home the point of the potential hazards of a particular hazard class. All of these outdoor chemistry demonstrations fall under the category of, now don't try this at home, kids. It could be really hazardous. I will turn it over to our chemistry expert, Lynn. Take it away, Lynn.
Good morning. Welcome to my backyard. Obviously, this area isn't big enough for all of you, and we're in the village limits here, so I can't make a lot of noise. The police are, to be honest, just down the street. We just talked about oxidizers, and the one thing that they definitely do is cause combustibles and flammables to ignite quicker. And we're going to be working with calcium hypochlorite. It's a strong oxidizer, and it is a pool chemical, readily available at big box stores and pool stores. And since there are over 10.7 million pools in the US, you could easily see some of these chemicals. Now we're going to react them with 2 items, brake fluid and antifreeze. And brake fluid is polyethylene glycol, has a flash point of 350 degrees, and it's the same, if you will, as ethylene glycol. The oxygen CH2 just gets repeated, where in the ethylene glycol it's just one time. Now when we react it with the oxidizers, they're going to first have to break this down because of all the long chain. An ethylene glycol is going to react much quicker, and we're going to put the fluid to it now.
In the slow motion portion of this video, there's another chemistry concept that is important to observe, and that's the idea of a flammable gas mixture being either too rich or too lean to ignite. There's a sweet spot where it's just the right mixture of air and flammable gas for it to ignite. And that's what we'll be looking for in this video, especially as the reaction really gets going. You're going to see a lot of vapor and smoke, but no flame. At a certain point it ignites, but you'll notice that it doesn't ignite close to the can. It ignites about 3 feet away, where the flammable gas mixture has had time to dilute a little bit and get that sweet spot of just right. So take a look for that.